we are going to have in 3 equations, you guys, with 3 variables. So everything we were just doing, we're kind of still doing. We're just going to do it with 3 variables, okay? So it's gonna feel familiar. Determine if the ordered triple is a solution. Okay, well, make sure when you plug them in, he works for all 3. There we go. Nice. This, Kiana's talking about having memories of this. And I'm like, yeah, I have memories of this that are so not fond at all. This was like the worst for me when I was in, I think Algebra 2 was when I saw it. And it just, I'm not neat. And I didn't get it. I didn't see the big picture. And this just flew over my head, you guys. Like, I remember because I wasn't neat, getting everything wrong, and then like just kind of going in circles and just being utterly confused and then not getting the answer like most of the time. That's my memory from it. I'm better now though, guys. So hopefully that you're not like me. Hopefully I can say the things that I needed to hear. You know what I mean? To be able to get it right. Okay, so this is just X, Y, and Z. So you plug them in for X, Y, and Z. So 0's gone. -4 times -2 is 8. And 8 plus 5 is 13. So this one totally checks out. Okay, so yuppers for that one. All right, now we're going to plug in 0, -2, and 5 into the next one. So 0 for the X, -2 for the Y, and 5 for the Z. 3 times 0 is 0. And you have -2, take away 5. Well, -2 minus 5 is -7. Okay, it's working so far. Just got to make sure it works for this third one. All right, 0 for the X, -2 for the Y, and 5 for the Z. Does that equal -1? Let's see. You're gone. -6 plus 5 indeed is -1. So our conclusion is it is a solution. So what's going on visually is last time we had lines, but now that I have X, Y, and Z, I don't have lines anymore. I have what we call planes. So you want to imagine a plane as it looks like a sheet of paper, but it extends infinitely. Like this is going to just keep going. We can't draw forever. Like it keeps getting bigger this way, it keeps getting bigger this way, it keeps getting bigger that way. We can't possibly draw forever, so we just draw a sheet of paper. But planes extend, just like a line goes on forever and we put arrows to let you know, hey, that keeps going. Well, with a plane, it goes on forever too. So you just have to imagine that piece of paper continuing on, okay? So what we're looking for is where 3 planes cross. So when you're getting an answer, like let's say this is your answer where that black dot is, right? That's your solution. You'll notice that is where all 3 planes intersect each other. The pink goes through that point, the green goes through that point, the blue goes through that point. Now, if I look for where just the pink and the blue intersect, the pink and the blue intersect in a line. Here's where they intersect. Remember, it's a line because this goes on forever. It's not a line segment, it's a line. Same thing with the blue and the green. They intersect in a line. They intersect right there. Okay, they go on forever, arrow, arrow. And then same thing for the pink and the green. They intersect right here, oops, right here. And on the other side of the paper, you can't see it, but it continues on, right? And so that would be the intersection of the pink and the green. Now, where do all 3 cross though? Right there at that corner. A good thing to visualize in your home is the carpet, and then where the carpet and 2 walls meet each other. That little point in the corner, the bottom corner of one of your rooms, right? Now, what could go wrong? Look at all the things that could go wrong, why we would not get an answer. Maybe there's no spot where all three cross. Yeah, two cross here, two cross here, and two cross here, but there isn't a point where all three planes cross each other in this little triangle situation. Okay, I call it the triangle situation because the way the papers are set up, they make this triangle. And so they're never going to cross all three in one spot. You could have all three sheets parallel and not touching. So imagine holding a sheet above another sheet above another sheet, right? And they never touch, okay? Or maybe two touch. Maybe two sheets are right on top of each other, but I'm looking for where all three cross. So if those two lie right on top of each other, but I make them parallel to the third and it doesn't touch the third, then there's no way all three touch. So these are our situations for how it could go wrong. It's quite a few, ways it could go wrong. Now, as for the infinitely many, there's a lot of those too. Maybe all three touch in this line right here, right? That's the line where all three cross each other. Maybe two are the same plane, like these two planes are right on top of each other right here, okay? So they're the same plane. And then you just take this other plane right here and you cross it with it and boom, it'll intersect right there. That's still infinitely many because that goes on forever, okay? Or unlike these two, all three planes sit right on top of each other. Three pieces of paper just right on top of each other. Where are they touching? They are touching everywhere, okay? All right. So let's do some of these. Now, we're actually going to describe the infinitely many on this case. We didn't last time, but we will this time. We will describe the infinitely many. Okay. I kind of ignore these things but whatever, I'll try to follow it, I guess. Let's see. So the first thing I do is I scan downward and I kind of go, which variable looks the easiest to eliminate? I look at my x's. I go, oh, those y's could cancel, a positive y and a negative y. Ooh, that might be good. I don't even have to do anything there. This isn't too bad. I could just change the signs, blah, blah, blah. So I'm kind of thinking, who looks easiest? So in my mind, I'm thinking the y's, you guys, look the easiest because of these two already being opposite of each other. So what you're going to do, I label them so we can talk about them with each other. I'm definitely putting equation A with equation B, okay? So I'm going to put equation A with equation B. That's going to be one of them. All right. Or 1, 2, 3, that works, Kiana. Yep. And I go back and forth. Some years I do that, and some years I do it like that. Okay. The next thing, you have to put two other equations together, any two you want. So here's what I'm thinking. I'm thinking B with C, because here's my reasoning. This one's already opposite of that one. Remember, we always want opposites. If that's a positive 6, then I want the other one to be a negative 6. So I'm not just going to straight up put B. I'm going to have to multiply B by 6. So that way this will become a negative 6. So I'm going to put that right here, negative 6 times B. By writing this, you're letting me know what your game plan is, and I can award you partial credit if I can follow. If you don't give me little tips like this, then I'm like, what happened? What are they doing? And then after grading 80 of these, I'm just kind of like tired, and I'll be like, oh, whatever, and I'll mark more points off because you weren't clear. I shouldn't have to be working super hard to grade your work, okay? And so this is a simple thing to write for me, right? I put B and C together, I multiply B times negative 6. All right, so C we did nothing to, so I'm just gonna straight up write C down. And you'll notice this is the day in my life when I started writing Z's like that. I remember this moment. Before that, I did not write my z's that way. But I'm a person whose 2's and z's look a lot alike, and it was dangerous for me. And so that's when I started using this whole line through the z thing, because I needed to tell the difference between my 2's and my z's. Look at this, right? You can see the dilemma. Okay. All right. Now I'm going to multiply -6 times b, you guys. You can either do it in your head or you can write it right here if you need to. But what we're doing is we're distributing the -6 to everybody, okay? So don't leave somebody out. So -6 times 2 is -12. A negative times a negative, a positive. A negative times a negative, a positive. And a negative times a negative is a positive. Okay, so everybody got multiplied by -6 in that equation. And now you're going to add downward, just like we did last section. So when we add downward, 1 plus 2 is 3, and your y's will cancel. If you make the y's cancel here, you have to make the y's cancel on the other side too. That was the thing my teacher didn't say, and I wasn't smart enough to spot it for some reason. Now I'm like, what was my problem? But I couldn't see it. If my teacher had just said, whatever variable you make cancel here, you've got to make that variable cancel on the other. Oops, I multiplied by the wrong thing. Let me do this again. Sorry guys, I'm a little tired today. Not gonna lie. Okay, let me just continue on right here. Sorry. So the positive y and the negative y cancel. A -1 and a -1 make -2. And -4 and -7 make -11. Okay. I shouldn't have multiplied by -6, you guys. I should have just multiplied by 6. Okay. Because I don't want to change the sign on this equation. I want the 12. I want this -6. Ah, that's what's going to make those y's cancel. A second ago, I had +6 and +6. Well, that's never going to cancel, right? So I chose the wrong value to multiply by. It should have been +6. I found it out when I tried to cancel. Okay, we're going to add downward here. So 12 plus 1 is 13. +6 and -6, bam, gone. -6 plus 2 is -4 and -43. Now, the reason why you had to make the same variable go away, if I'm doing y's on the first two, I got to make sure it's y's on the second two, is because now these two equations will have the same letters, and you can put them together. Okay, so let me write that out on this first case, okay? The reason why, if you eliminate y's in the first set of equations, you also have to eliminate y in the second set is so that the remaining equations have the same variables, x and z. If you got rid of the y's in both, then that means the x's and the z's will stick around. So that means we can put these together now. So that's what we're going to do. Now we're back in 5-1. This isn't a 5-2 problem anymore. Okay, so I'm thinking, x's looks a little tough. I could get rid of the z's pretty easily. If this guy is a -4, then I want this guy to be a +4. So in order to change that -2 into a +4, we're going to need another -2. So let's see what we get. -6, +4, like we wanted. positive 22. And then recopy this one. Alrighty, these guys just straight up cancel, gone. And we get 7 equals negative 21. Oh yeah. And 7 goes into 21 3 times. So we have our x. Now with these, what you're looking for is an x comma y comma z. We got the x. Now we got to get the y. So take them back to your favorite. Either here, not at the beginning. It's either here or here. So I'm thinking that I'd like to plug them into that first one. That one looks simpler to me. So we're going to go ahead and say x is really negative 3. So negative 3 times 3, this is negative 9. We'll add that 9 over. What is that? Negative 2. And we'll divide by negative 2. Z equals 1. Hey, we got our z. So now we just got to hunt our y. So at that point, you take both x and z to one of the originals. It doesn't matter who, whichever one looks easiest. I know which one I'm thinking looks easiest. I'm thinking the top one, you guys, is where I want to go with it. So if I plug in negative 3 for the x, and I plug in 1 for the z, I should be able to find y. Combine like terms, negative 3, negative 1 is negative 4. Add the 4 over. You get y equals 0. There it is. There's our solution. It's kind of cool to look at a picture. One of the reasons I like GeoGebra is they were the first ones with 3-dimensional graphing. I don't know if Desmos does that yet. I haven't checked it out, to be quite honest. But let's go check out the 3D grapher. Where is it? There we go. So this is kind of cool. There's your X, Y, Z axis. Okay, you can pick this up and move it around too. So let me go ahead and type in those equations and let's see what we're staring at. What am I doing? That's not that one. Okay, so negative 3, 0, 1. There it is. Okay, you can't really see it. There it is. Okay, so point in space. All right. Now what we want to do is we want to put in those planes. X plus y minus z equals negative 4. Boom. There's one sheet of paper. There's one plane. 2x minus y minus z equals negative 7. Bam, there's another plane. Oops, I don't like that they made them the same color. I'm going to change that guy to like orange or something. There we go. Well, that's not what I want. That's pretty much okay. Ooh, it's making a pretty ugly brown. I thought it was supposed to be orange, you guys. Yucky. I don't like that color. Sorry. Let's try that again. We'll just go for a nice red. Ah, I keep doing that. Wrong X, wrong X. There we go. Gosh, that's a funky color. Okay. So there's those two planes. They both go through that point, you guys. I don't know if you can tell. Right there's the blue one going through that point. If I twist like this, you can see the red ones going through that point. Okay, cool. They both go through that point. That's a good sign. Let's put in our third equation and make sure it goes through that point. X plus 6y plus 2z equals negative 1. Bam. Let's see how we did. Let's make that guy a different color too. So settings, I don't know, color. Let's go green, I guess. All right. Oh, it changed them both. What's with that? That's not what I wanted. Okay. All right. So indeed, all three, see there's the green one going through it, there's the blue one going through it, and if I can twist some more, there's the red one going through it. How cool, that's the point, where all three cross, right? All three intersect. So let me try to get a good picture where we can see that. I don't know, you guys, where is a good picture? Maybe that? It's kind of hard to see this, huh? There, I'll do that. All right, so let me go ahead and go to the next slide. I'll get you a nice picture of what you have going on. Bam, there it is. All right, pretty cool, huh? Has anybody else like, I don't know, I think that's neat. Now we're in 3D space. This is where you guys have gotten to. Okay, let's do another one. Oh, so I'm just going to delete that slide because we already did that. All right. Okay. So again, we don't like fractions, right? Let's get rid of them. Okay. So I'm looking at this first equation going, how can I get rid of the fractions? All right. So the LCD is 6. So we're going to do 6s to all the numerators. All right. So we got 6x. 2 goes into 6 3 times. So we're going to have a negative 3y there. 3 goes into 6 twice. So that's going to be a 2z. And then we have the 30. All right. So that's going to help us fix equation number 1, you guys. All right. So this was just us getting rid of the fractions right here. So here's our system. We got this. Oops. Oh, this one only has an x and a z, huh? There we go. Okay. All right, you guys. So here's how I do this. When one is already missing a variable, box it. So in other words, this one's done. Remember, we worked hard to get rid of the variable, okay? So since y is missing, go to the other two and make y go away. Okay, so let me just start a new one, I guess. It's like half the work, right? Let me kind of make sure you guys understand what I'm saying when I say it's half the work. We had to put 2 equations together to get it down to 2 variables and another 2 equations to get it down to 2 variables. Well, if they already gave you one that has just 2 variables, cool, then this part's like already done. You just got to put the other 2 together and make that same variable go away. So here we go. So all we need to do is put together equation, dun, 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 A, B, C. Put equation A and equation B together and make the y's go away. All right, here's equation A. 6x minus 3y plus 2z equals 30. Now, if this guy's a negative 3y, then we want this one to be positive 3, because negative 3 and positive 3 cancel. So in order to make it a positive 3, what would I need to multiply by? Yes, because the two negatives will turn that guy into a positive. So we're going to multiply the second equation by a negative 3. All right, let's do it. So we're going to do a negative 3 to that. All right, negative 3x, positive 3y like we wanted. Awesome. Positive 3z, and positive 3. All right, let's see what we got when we go downward with it. 3. These guys are goners. 5 and 33. Now, box it. These two can go with each other now because they both have x's and z's in them. So that's going to be our next step, is we are going to put those two together. So here we go. Oh my gosh, you guys, I didn't see that that was negative 3y. Oh my gosh, you guys are going to kill me. Maybe not, maybe not. I didn't see this y. I chalk it up to lefty issues, covering stuff up with my hand. Okay, so I totally lied on this part, at least. Some of it we get to keep. Oh man, Mecklenburg. Okay, it's not too horrible. Let me take this. Normally it lets me just grab that. All right, I'm just gonna do this, guys. Okay. It has a Y. Hello. Okay. All right, so for that last equation, you guys, just shoot this guy over right here. That's where we want him to be, right? We want to have the Y right in the middle, just like everybody else. So this is 6x plus 3y plus c equals 0 over here. Okay, so this equation, this is my new equation C right here. We manipulated it so that they're stacked up nicely. Okay, so let me just kind of erase right here really quickly and move this over a little bit. Uh-oh, is it gonna let me? Yeah, it is. Okay. Just move this out of the way. Yes, there we go. Okay. All right, guys. Okay, take care, Kiana. All right. She's like, I'm out. You messed that up. I didn't see that Y, you guys. I apologize. So, stuff like that. I wish I could stop doing it, but you know, this happens every now and then. Okay. So we put together A and B and we got rid of the Y's. So that means that we need to put together two other equations and get rid of the Y's. I'm looking at this equation B, this negative Z, and I'm sorry, this negative Y and this positive. No, I'm looking at A and C. I'm lying. Do you guys see how this is a negative 3y and this is a positive 3y? They're already ready to go, you guys. So let's go ahead and put those together. So we're going to put A and C together. And we don't have to do any multiplying. They're already ready to go. Check it out. Goners, without us even really trying there. So that's cool. We'll take it. All right, 2z plus 1z, 3z. There we go. Okay, so now we know what to do. We put these two together. Okay, so I'm going to stack them so we can stare at them for a little bit and see what's going on. All right, so I think it'd be easiest to get rid of the x's because if we multiply by a -4, there's our -12 and our +12. If you had to get rid of the z's, you guys, you'd have to multiply, make them both 15 and -15. That'd be a lot of work. So I'm thinking, let's get rid of those x's. So this is what we got. Four times 33, I'm going to the calculator for that, 132. All right, we got -17, and then 132 -102. And then divide by 17. 6. Whole number. Okay. All right. Take that. Don't go back to the beginning yet. You go to either here or here with that. I'm looking at the one on the left thinking it looks a little bit easier. So that's going to be my choices. I'm going to take them back to the left right here. So if I do that, I'm going to get 3x plus 5 times z, which is 6. And now I can solve for the x. Bam. Now, where do we go now that we have 2 of them? Where do we go now that we have 2 of them?
To the beginning.
To the beginning.
To the original ones.
Yeah, whichever one of the original ones you want. I don't know about you guys, but I'm liking this guy right here. He looks pretty easy, right? X minus y minus z equals 1. Feel like I can handle that right now. All right. So x minus y minus z equals -1. X is 1. Z is 6. So if we put the 1 and the -6 together, we get -5. And then just solve for the y. So add 5 over. Divide by a negative. Y equals -4. So here, ordered pairs, x comma, ordered triple, sorry, x comma y comma z. So make sure you put x, then y, then z, and let's see how we did, if this is really where these planes cross, okay? So I'm gonna graph that point, 1, -4, okay, there he is in space, okay? Let's put in those planes. Sorry, guys. Oh, sorry. Okay, there's one plane. I put the easy one in. X minus 1/2 y plus 1/3 z equals 5. And then 6x plus z equals -3y. Okay, now let's make them different colors. Settings, color red for you. And let's go blue for you, I guess. Sure. Okay. Now hopefully all of them go through that point. Let's see. Oh, look at it, you guys. The red one goes through it, the green one goes through it, and the purple one goes through it. It's perfect. Okay, so I'm trying to get a good picture. I guess that's a good one right there. That shows that all 3 planes indeed go through it. Very, very cool. Okay. I don't need to be that big. All right. There we go. Okay. Okay. So it doesn't matter which equation you pick. But if one of the equations only has two variables, then box it. I could pick either one in this case and that'd be fine. For example, let's say that I decide to come up here and box this one and say this one's done. Then I would put these two together. And since this one has no z, right? It's got no z in it. Then I would put these two together and make the z's go away. And that's actually my favorite plan, but it's not the one you have to do. Let's say that you boxed this one and considered this one as finished. Well, that one is missing its y value, right? There's no y. Well, then I would put these two together and make the y go away. Remember, the key here is whatever variable is missing, make sure you make that same variable disappear with the other two as well. You don't have a choice. You got to make the same one go away. Okay, so I'm going to say, let's box the first one since it only has two variables. Okay. And then notice it's missing y, right? Since it's, z, sorry. Since it's missing z, put the other two equations together and get rid of z. Okay. So anytime, guys, one equation has only two in it, box it. It doesn't matter which one, pick one. Okay, so I'm going to consider this one is done. And so now we're going to put equations B and C together. Okay, so we're going to put B with C, and we don't have to do anything. Check it out. This guy's a negative Z, this guy's a positive Z. We don't have to multiply anything, you guys. We can just straight up go for it. It's going to cancel already. Okay, so let me line them up properly, though. We got 2x. We got a negative z equals 4. And then we've got x plus y plus z equals 29. All right. So if we add downward, 2x plus 1x gets us 3x, this positive y, and then those cancel. So you'll notice, I think that's 33. I'm going to box this. So you always put your two boxed equations together. So this guy and this guy, they're going to go together in our second part. Okay, so I'm going to go ahead and stack them. Let's see what's a good color ink. Let's go black. We haven't used that yet. So we've got x plus y equals 19 that we're going to put with 3x plus y equals 33. All right. What do you guys want to get rid of, x or y? All the way, right? Is everybody going, yeah, look at those y's. Yeah, okay. So it doesn't matter how you do it. What I'm going to do is I'm just going to go ahead and say, let me multiply this by a negative. Okay, so let's see. I could have done it to the bottom one too, you guys. So it doesn't matter. Just pick one of them. I just need to make sure that one of those y's is negative. Okay, so these cancel like we want. -1 plus 3, that's going to be 2. And 33 take away 19, was that 14? I'm going to go for it. All right, divided by 2, x equals 7. Okay, so as far as our ordered pair, you guys, we got 7. Ordered triple, what am I talking about? I'm in three-dimensional space here, right? X, Y, Z. Okay, now do you guys remember where we go with that? Do we go with that 7 back to the very beginning?
No, we go where B and C is.
Yeah.
We like group them together.
Yep. So you can go with B or C, yeah, either one, or one of your any of your boxed equations. It doesn't really matter. And in this case, we actually could go back to the beginning, but only because the beginning had equations that only had 2 variables. Okay, so in this particular case, I guess we could go back to the beginning. So here's what I'm thinking. If we take this x back to here, what will we be finding?
The Y value.
The y value. And if we take this x back to here, Then we'll be finding the z value.
The Z value.
Yep. So that can do it. So sometimes we, veer off the typical course because they gave us different stuff than they usually give us. Okay. All right, so I'm going to plug 7 in for the x. All right, let me get all my stray marks off here. Okay, so take away 7, it must be that y is 12. All right, cool. Let me go put that guy in. All righty. And then for green, we're going to take this equation right here, but we're going to be putting 7 in for the x. And there could have been other things you did, you guys. So if you saw something you think's easier, go for it. Okay, I'm going to take away 14, Negative z equals negative 10. So z must be positive 10. There it is. Okay. So I asked you guys what these were. I said, are these lines? And I got silence, dead silence. All right, let's go figure out what these are, you guys. Remember, GeoGebra has a 3D calculator. And we graphed these in 3D space last time, right? Okay, so let's go and see what one of these are. I'm going to graph x plus y equals 19. Okay, enter. All right, where did it go? I'm wondering what happened to it, you guys. Am I having a moment here? Maybe it doesn't like that there's 2 variables, so let me put in another one. Now that one showed up. Where'd the red one go? Oh, I know why. I gotta zoom out. 19's not on our graph. There we go. Whoa, where did he go? Okay, let me try this. Hey, getting used to this. Okay, so these aren't lines. What are these called, you guys? Like, what is this blue thing called? And what is this pink or whatever red thing called?
Platforms?
What was it?
Platforms? Planes?
Planes, yeah. You knew it was a PL word. Nice, yep. So they're planes. So we want to see where the planes intersect, right? And there's 3 of them. Right now you can see these 2 intersect right here in a line. If we do one more, let me put the point in that we got too, so we can see that they definitely crossed there. 7, 12, and 10. Okay, let's put in 7, 12, and 10. Okay, cool. The point is where these 2 planes cross. If I go and I put that 3rd plane in, you guys, because I haven't put the 3rd one in yet, I bet you it's going to go through that point right there. Okay, let's see here. There we go. Let me make that guy a different color so we can see him. It used to be they'd always make everything a different color. That was the settings, but I don't know what happened to GeoGebra. All right, there you go. So you can see that the pink, the green, and the blue all go through that point right there, right? Let me get a nice picture of that guy. I'm going to put him on the next. There we go. All 3 planes intersected at 7, 14, 10. And that is what we wanted.
It's 12.
12 instead of 14?
Yeah.
Thanks. Okay. All right, pretty cool stuff that you guys are getting into. This is exciting. Okay, any questions on that one, you guys? You took a different path than the usual. So key thing is if you see that one of the equations only has 2 letters, box it, put the other 2 together, and make sure you get rid of the same letter that's missing, okay? All right, let's try some more. Let's get really awesome at these. Okay, so let's get these all into standard form. That's going to be the first thing we can do. Or you could do substitution, but I always just put them in standard form. Get all equations in standard form. Okay. Here we go. All right, so for the first one to get into standard form, all we have to do is take this and shoot them over to the other side. So that'll be easy. So it's going to be 2x plus y minus 3z equals -3. Okay, so we just change signs because we crossed the equal sign, and then put it in alphabetical order. So that one's done. All right, let's work on this next one. So we're going to go ahead and distribute the 2, right? So let me write it down here to show all the work. All right. So we got 4x minus 6z plus 2y equals -6. Okay, rearrange them. Alphabetical order. Okay. All right. So done, done. And the last one's already done, except for it just needs to be rewritten. So alphabetical order. So for the last one, it's 3x minus 2y plus 4z equals 1. Now that one's done. Okay. So we're going to put these all together. So probably the easiest thing to do would be, let's just write them over here. Okay. And we'll kind of stare at them and see what variable we want to get rid of. I have a feeling I know which one I want to get rid of. Let's see if you guys are thinking the same thing. Okay, guys, if you're looking downward, you know, at all the x's, at all the y's, and at all the z's, which variable seems the easiest to eliminate? Yeah, you bet. Look at these guys. Do you guys see the positive 2i and the negative 2i? That looks really good. Okay. All right. So we're going to put equation B and C together for sure. Like, of course, we're using those two. Okay. Now, if we put those two together, which we're going to, and we make the y's go away, then don't forget that when you pick any other two equations to put together, you have to make the y's go away there also. So here's what I'm thinking. I'm thinking about putting equations A and C together, okay? And now C, just as it is, I'm not going to mess with it. 3x minus 2y plus 4z equals 1. Since this is a minus 2y, I want this to be a plus 2y. So I would have to multiply it by a 2. So I'm going to show the teacher who's having to grade this stuff that I multiplied by a 2 by just putting this little times 2 in front of it. So when we copy everything down over here, you guys, make sure you multiply this entire equation by 2 when you write it down. So 2 times 2 is going to make this 4. 1 times 2 is going to make it 2. Negative 3 times 2 is negative 6. And negative 3 times 2 is negative 6. All right. We are all set up to add downward. So here we go. You're gone. Oops, I don't know why I'm writing negative 6. Okay, this is weird because we normally put these two together now, right? Okay. Let me put that over here, I guess. If we put these two together, and we were to multiply, let's say, the bottom one by a negative, hoping to make some stuff cancel, right? What's going to happen, you guys?
It all cancels.
It all cancels off. You're like, oh, it canceled, all right. All of it went away. Okay, so the question is like, okay, what does that mean when I get 0 equals 0? You guys remember what it means when that's a true statement?
All real numbers.
Close, close. You're super close.
It's dependent.
Yes. Okay, so it's infinitely many. Infinitely many. The reason we don't want to say all reals, right, which was close, is because of consider the following in 2D. When you say all reals, you're saying everything works, right? But if I have like a line on top of another line, for example, right? All of these points work, and there are infinitely many of them, right? Because this goes on forever, right? Okay, but not everybody's okay. That's not a solution. That's not a solution. That's not a solution. So we can't say like all reals, but I see why we want to say that, huh? Because that makes it seem like infinitely many. Okay, so the better choice of words there, you guys, would be infinitely many. Okay, now sometimes on these types of problems, by the way, you're right, it would be a dependent. So let's talk about that. So as far as what's the solutions, this is describing the solutions. There's infinitely many. Now, let me kind of just look at this and see here. Sorry, you guys. I'm trying to think if they'll be okay with that. Okay, so what I wanted to say was, if the directions say, what are the solutions? Then the answers that you want to give out are either a point, this could be one possibility, or you can say infinitely many and describe it. Okay, or 3, no solution. Now, when do they want us to use the words like consistent, inconsistent, dependent, independent? That would be if the directions say, what type of equations are they? What type of equations or lines or planes are they? That's when you're going to say independent, dependent, consistent, inconsistent. Okay, hopefully that helps, like when I use what. Okay, and we know that this, you're right, this goes with this, right? And then, I'm sorry, I shouldn't write it like that. Dependent goes with that, and inconsistent goes with that. Those are the big ones to remember. There's more, but those are the big ones. Okay. All right, so infinitely many solutions here. As far as how you would describe these solutions, sometimes they continue on and they just write it like this. Let me kind of move the screen up, trying to figure out where to fit it. These problems get so long. If you were to describe the solutions, you can say all x, y, z such that, and then write down this plane where they intersect. This is one way to describe all of the solutions. Okay, this really is infinitely many solutions. This is a line here, isn't this? 7x minus 2z equals 5 is a line. And so you're saying all points that lie on this line. Let me type that out. What you're saying here is all points that lie on that line. All right, let me move this over. Let me shrink it, I guess. All right. So let's go look at a graph because it's like, what? Okay, so let's go see what this looks like. I'm curious. Let me delete these guys out and show you what I'm talking about. sure I type stuff right. That one looks good. Okay. 2 parentheses 2x minus 3z. Okay, let's make these different colors. Red, blue, purple, yes. All right. So there's our purple one, right? So that's this one down here. Okay. And then we have like this pukey color. Let me just make sure it's always that pukey color. Sorry, guys. I lost where. Come on. No, don't do this to me. Sorry when my computer gets behind a little bit. Sorry, you can tell I don't work with GeoGebra. It just looks like it's spinning. There, okay. And it's spinning when I'm not even touching it. That's interesting. There we go, okay. All right. The thing here is, there's the purple plane. This putrid color is because it turns out that this second equation is this plane, but so is the top equation the same exact plane. So these top two equations are the same plane. So if I want to know what the answer is, what the solution is, it's going to be, this is great right here, it's going to be this line right here. Any point along this line is a solution because all three planes go through that. The purple plane goes through it. And of course, the blue and the red do because they're this pukey brown one smushed together, right? So they all go through that. And that is what you just described right here. This 7x minus 2z equals -5, that's a line, you guys. And that is the line in the picture where those planes crossed. So this is better. Like, why can't I just get away with infinitely many? Well, you haven't described to people where the solutions are. When you write this down, you're saying, yeah, okay, it's infinitely many, but let me tell you a little bit more about them, okay? It's going to be all the points that lie on this line. So for example, just to kind of show you what I mean in more detail, okay, if I were to pick, come on, Bo, if I were to pick some points that satisfy that equation right there, that's 7x minus 2z equals 5. Let's go look at it in more detail so you know why this is important. What does this even mean? Okay. Oh my gosh. So we need to try and find some points that satisfy it. Okay, what if x were 1? If x were 1, then we'd have 7 minus 2z equals -5. Let me try to solve for the z really quickly just to kind of show you guys. Okay, it looks like 6 would be the z. Okay, and notice y isn't even in that equation. So what does it mean that y isn't in that equation? It means y can be whatever. You know, pick a y value. Doesn't matter, you put them in there and it should work. Okay. So let's double check my math here. If that is a 6, yeah, that should do it. Okay. All right, let's plug this point in and see if it's on that line. 1, 2, 6. Is it on that line there? It's higher up. Oh, so this is hard to tell. I wanted it to be exactly on it. Because remember, these planes go on forever. Is it even on? It's not even on the intersection. So I'm wondering what I did wrong there. I might have to think about this more, you guys, to get to a good point that's going to show up. Should have been on that line. Okay. So anyhow, let me take a picture of this. And where was that good one? I want to see where the red, I guess this will do. And then I'm going to highlight it in our right here. And I'm going to go ahead and say, these are all the solutions right here. So this line, let's do this. This line is the solution, because that's where the red and the purple crossed. So any point on that is going to be a point that's going to work for the given equations in the beginning. Okay. All right. I want to make sure you're not just doing math. I have students who are like good at getting answers, but they don't know what's going on, and that's scary. I don't think you're really doing anything for yourself there. So that's why I'm continuously showing you these pictures so you know, okay, infinitely many, I'm writing this down. Why? Oh, I'm describing the infinitely many. I'm describing, sorry, the points that will be solutions to all of them. Okay. All right, let's try another one. That one was trickster. Number 5. Okay. Okay, so they're already in standard form. Cool. We don't have a lot of work to do. Let's take a peek at what variables we want to put together. Do we want to put the x's or get rid of the x's? Do we want to get rid of the y's, or do we want to get rid of the z's? Do you guys have a favorite?
Z's.
Yeah, I'm thinking z's too, you guys. Okay, let's label these so we can talk about them. Call this guy A, B, and C. All right, what 2 equations do we want to put together, like, for sure?
A and B.
A and B, because one of them's, they're both z's, huh? Okay, so let's say that we write down equation A and we don't change it at all. Okay, so here's equation A unchanged. What are we going to have to do to equation B so that the z's will cancel?
Multiply by a negative.
Yes, okay. So we're going to need a negative multiplied by that equation B. So we're going to change all the signs when we write it down. And here we go. So we got 2x plus 5y, these guys are goners, equals -1, box it. Okay. So we put A and B together. Let's say we put B and C together. We have to get rid of Z again. There's no choice. It's gotta be Z. So this guy's a -2Z. So I'm gonna keep that equation exactly the same. And I want to try to make this Z in equation B cancel with it. So it'd be nice if it were 2, right? Because 2Z and -2Z will cancel. So what would we need to multiply equation B by?
2.
A 2. All right. So we're going to go ahead and multiply equation B by a 2. So here we go, 2 times it. So when I write it down, everything is going to be multiplied by 2. So 2 times x, 2 times -3, and 2 times z, and 2 times 4, which is 8. Okay. All right. So now we've got that. Okay. We're going to put those 2 together. So let's go ahead and put those together. And let me just write this one. Here's what I'll do. I'll put this one underneath. Okay. No, you know what? It's your notes. Sorry, guys. I'm trying to be neat. It's not natural within me to be a neat person. So you're going to hear me rewriting stuff over and over again. Okay. All right. So looking at that, it doesn't matter who we get rid of on this one, it turns out. So let's say you're thinking x's. It's like, okay, if this guy's a -4, then I want this to be a +4. So let me multiply it by a 2. Let's see what happens. Okay, it's one of those weird cases again, right? Okay, so what's the difference between this one and the last one?
there's a solution in this one?
Yep, this is no solution. This is a false statement, right? So instead of saying we got infinitely many solutions, we're saying there's none. There is nowhere where all three of these planes are going to intersect each other, right? There's nowhere where all three of these planes intersect. Let's just double check that that's the case. Okay, so we got 3x plus 2y plus z equals 3. So that's that green plane. X minus 3y plus z equals 4. Let's change the color on that guy. All right, so that's that pinkish looking one. All right, negative 6x minus 4y minus 2z equals 1. And we'll make this guy, let's go with purple. All right. All right. So, oh, this is a perfect picture. Look at that. So there's nowhere where all three planes cross each other. The purple crosses the pink right here, right? The green crosses the pink right here. But the purple and the green never touch each other, right? They're parallel. So because they're parallel to each other, then there's no place where all three planes cross each other because those two never cross each other, okay? So that's why we're getting no solution here. It's a good picture. Maybe I'll snap right there. Okay, so we can see we're getting no solution because those two planes were parallel. Okay. So we are getting no solution because two of the planes are parallel. That implies that there is no point at which all three planes intersect. Now, you can actually spot parallel planes right away, sometimes, okay? This first equation and this last equation are almost a multiple of each other. Notice if you multiply by negative 2 to the 3, you get negative 6. If you do negative 2 to the 2, you get negative 4. And if you do negative 2 to the z, you get negative 2. So just by multiplying by negative 2 to this, all of these match. However, when I multiplied by negative 2 to that, it didn't match. That implies parallel planes. If I multiplied everybody by a negative 2 here and it 100% matched down here, then those would be planes on top of each other, okay? So the fact that the right-hand sides didn't match said, okay, they're still going to be parallel, but they won't be right on top of each other. So sometimes you can spot what you're going to get as a solution before you even start the problem if you can look and see, oh, one's a multiple of the other. One's a multiple of the other, okay? Pretty cool, okay. You know, I'm looking back on this one, I'm still thinking, where is my mistake here? And, oh, let's see here, I can get, yeah, I can't figure out where I made the mistake on that one. All right, I'm gonna have to think about that. Maybe on the 10-minute break and I'll come back to it. Don't waste your guys' time. Your time is valuable at this point, right? You're like, I could be studying for my finals. All right. Okay, so word problems. So how do we apply these things? Let's see. Yeah, these are not bad ones compared to those ones we did in 2D. These are actually pretty nice. I think you guys are gonna like number 7. So you guys know how to write the equation of a line that goes through 2 points. That's something we've done in this class. What we're gonna do now is we're gonna find the parabola that goes through all 3 points. 2 points isn't enough. If I have 2 points, then I could draw so many parabolas through that. I got an upwards one. I got a downwards facing one, right? I've got an upwards one, or where it's a little bit wider, I guess. You know, I could draw parabolas all day through those 2 points. So nobody would ever give you 2 points and say, find the parabola through them, because there would be infinitely many parabolas. So given 3 points though, now there's only one parabola. Let me draw them kind of in a weird spot. Now there's only one parabola that could possibly go through all of those. Okay, I don't know if I can even draw this parabola. Something like that, right? There's no other parabola that could do it, you guys. Okay, it's definitely downward facing. It's unique, in other words. It's the only one. Now what we're gonna do is we're gonna try to find that. So for example, they're giving us these 3 points. Let's graph them, take a peek at them. This would be in 2D. So let me just do the 2D. Okay, so let me go ahead and type those in and we can kind of like see what I'm talking about, how there's only one parabola. So 1, 9, -2, -24, and 3, -19. All right. I gotta definitely shrink the y-axis a little bit here so you guys can see it, but let me stretch the x out a little bit. Okay, so that's what we're looking for. We're looking for the parabola that goes through those 3 points. You know, if we could guess ahead of time, would you guys say it's an upwards facing or a downwards facing just by looking at that?
Upwards?
Upwards? So you think you can draw an upwards parabola going through that?
Down. Sorry, down.
Down? Yeah. I think probably a down, huh? It looks like maybe something like that-ish. Okay, sorry, I just can't draw a straight line at all for the life of me. So something like that, okay? All right, so let's go in here and see if we can find the exact equation that's gonna go through all 3 of those points. Let's see. All right, so the way that you do it is you're gonna use y equals ax squared plus bx plus c 3 times. And you're gonna be plugging these all in as x and y each time. Okay, so the first time around, I'm going to plug in 1, 9. So I'm gonna put a 1 in. I'm gonna put a 9 in for the y and a 1 in for the x. And then I'm gonna clean it up. Okay, then I'm gonna do the same thing for the next point, this one here. So -24 is the y, -2 is the x. I'm just plugging them into this over and over and over again. All right, now if I clean things up, I have -24, -2 squared is 4, -2b, and c. We'll do it one more time. Now I'm going to do it with the last point, 3, -19. -19 is the y, 3 is the x. And now you see why this is in this section. You're like, oh yeah, this looks like what we've been doing, okay? Now there's no thinking about it. When you see this, I mean, which letter do you guys want to get rid of, A, B, or C? I think, yeah, the choice is obvious, right? It's like, we're definitely getting rid of C, okay? So on these types of problems, it'll always be C that you get rid of. So let's say that we put A together with -b. So I'm going to take B and I'm going to multiply it by a -1. So A will stay the same, but B will have all of its signs changed. That way the C's are opposite of each other, right? That's the whole goal, is to make those C's cancel. If they were both positive, well, I got to multiply one of them by a negative then. All right, so we got 33 equals -3a plus 3b. The C's are gone, box it. All right. Now put any other 2 equations together. It doesn't matter which ones. Do you guys have a preference? We already put A and B together. Okay, I'll pick A and C. So let's say we put A and C together. And let's just multiply a -1 times c. So he has the opposite sign again. So A doesn't change. But C, every single sign will be the opposite. I can't add. Let's see here. I think it's 28. Yeah. Let's cancel. I always double check my math, you guys, because these problems are so long that I don't want to invest time in it if like I'm wrong at the beginning, you know. Okay, now we put those two together, right? So we're going to stack those two on top of each other. So let's go ahead and write it over here so we have a little bit more space. Okay, it doesn't really look like there's anything like super easy to get rid of. But I probably would pick the B's if I could pick. So let's go ahead and multiply by a 3 here so it will create a -6. And let's multiply by a 2 here so it'll create a +6. So let me move these arrows a little bit over to get out of our way a bit. Oops. There we go. Okay. So we multiplied by 3 here. So we're going to have, I don't know, 3 times 28, calculator time, 84. That I can do. 3 times 8 is 24. 3 times 2 is -6. 2 times 33 is 66. 2 times -3 is -6. And +6. All right, these guys cancel. 10, carry the 1, 150. That's -30. Oh, it's so great when the numbers work out well. 30 goes into this guy, -5 times. You could cross the zeros off and just say, okay, 3 goes into 15. Hey, that's a good sign. Because we said, we know that our parabola faces downward, you guys, right? So what you already know right now is that this is a -5, which means our parabola faces downward. So that's good. Now we just got to get B and C. And we said, you don't usually want to go back to the beginning. You want to go back to one of your boxed equations and plug it in there. Doesn't matter who, just take them back to one of them. So let's say you put them in, let's say you put them in, you know, right here. All right, let's see what that's going to give us. 28 equals -8 times -5. So 28 equals 40. You know what? I just don't like these at all. They're in my way everywhere. But I feel like you need them to see where we're going because there's so much work. All right, let's take away 40 from both sides. That's -12. So if you divide by -2, it looks like B is going to be +6. Okay, so if we take that back, we know we have a +6x now, right? If we were to take that and plug it in. And then finally, we need to get C, right? So if we were to get C, take your 2 all the way back to the beginning. And I like this one the best right here. Look how easy that one looks. Okay, so let's go ahead and take A and B back to the equation right here. So 9 equals A plus B plus C. 9 equals 1 plus C. Take away 1, take away 1. 8 equals C. So here is our equation of the parabola. Let's check it out and see if it worked, you guys. See if that goes through those 3 points like we were kind of hoping it would. Let's check it out. All right, let me put that guy in. So we're saying -5x to the second plus 6x plus 8 equals, I'm not even typing. I don't know what happened there. Oh, all right. Apparently my Surface Pro wants me to have it upright when I do that. Okay. plus 6x plus 8 equals. Look at it, you guys. How perfect is that, right? That is so cool. Okay. So I'm going to get a screenshot. Let me take it to the next slide. And let's go ahead and write this down. And we got -5, 6, and 8 as our ordered triple. Those are what you're going to plug in for your A, your B, and your C. Cool. All right. So you guys have that power now. So not only could I give you 2 points and say, what's the line that goes through them? I could give you 3 points now and say, what is the parabola that goes through them? Okay. All right. Oops, I thought we had a word problem. Did I do them out of order, you guys? The heck? I did do them out of order. How did I skip 6? All right, number 6. The largest angle in a triangle measures 22 degrees more than 3 times the smallest. The middle angle measures 4 more than the difference between the largest and the smallest. Find the measure. Okay. All right. So I am going to go ahead and let people know what my variables are going to stand for. So I'm going to go ahead and say, let's let the largest angle be x. Let's let the middle angle be y. And let's let the smallest be z. Doesn't matter, you know, somebody next to you might have labeled them differently. Who cares? Okay. All right, that's just so we can start writing some equations here, you guys. Okay, so I'm reading through these and I'm going to stop at the period. That's going to be one of my equations. The largest angle in a triangle. Okay, so x, right? Measures 22 more than 3 times the smallest. Okay, 3 times the smallest. Well, we just labeled the smallest as z. So there's one equation right there. The largest angle in a triangle is 22 more than 3 times the smallest. 22 plus 3 times z. All right, let's go to the next equation. I'll stop at the period. The middle angle. All right, well, we know the middle angle is what we're calling y. So y measures 4 more than the difference between the largest and the smallest. What does difference mean again?
Subtraction.
Yeah. The difference between the largest and the smallest. So x is the largest, z is the smallest. So it looks like they want us to do x minus z. So let me just make sure it sounds right. The middle angle, y, is 4 more than 4 plus. The difference, so I have to subtract, between the largest, which is x, and the smallest, which is z. Now, there's a rule that says if you have 3 variables, you need 3 equations. That is the rule, you guys. So we're missing an equation. If you have 3 variables, you need 3 equations. So we're missing an equation. What do you guys think? There has to be something else in our life that we know that's going to help us get a 3rd equation. Let's see. These are angles in a triangle, huh? Let's see. Yeah, so these are 3 angles in a triangle. Okay, so what do we know about the angles of a triangle?
They all add up to 180.
Yes. Okay, so. That's where we're going to get our third equation. All right. So our third equation will look something like this. X plus y plus z equals 180. Okay. So they really only gave us information for 2. We had to infer the third. That's dangerous. You got to be on your toes for that. Okay. All right. Let's get these guys in standard form. We know the drill. We don't like them to be all out of order and stuff like this. Okay. Now I'm going to go ahead and box this one because it only has 2 variables. Remember we said if any equation only has 2 variables, box it. That one's done. Okay, done. Don't mess with him. So what I'm going to do is I'm going to rewrite the green in standard form. That means that I'm going to move x over with the y. I'm going to move z over with the y. And I'm going to leave 4 where it is. So this guy went over here. This guy went over here. That's why their signs changed. Now look at how great that is, you guys. We don't even have to do anything. Let's add downward. Those x's are already ready, primed and ready to go, right? So we had 2y. Oh, I can't. Never mind. I'm lying. It was too good to be true. Okay. So let me box this and put a little comment here. Since y is missing from the blue equation, we need to make y go away. We don't have a choice. Okay. So that should be a pretty easy thing to get accomplished, right? So let's just say that we leave the red the same. If we leave the red one the same, what are we going to have to do to the green one so that the y's cancel?
Multiply by a negative.
Yep, multiply it by a negative. That's going to change all the signs on us. So negative x will become positive x, positive y, or negative y, etc. Okay, let's see what we got going on. Bam, you're gone. You're gone. That was nice. So 2x equals 176. If you cut 176 in half, half of 16 is 8, I think it's 88. Is that right, you guys? 88? We'll go with it. All right, 88 is x. All right. So now, cool. Let's just take that back here. And we now have z. Okay, so on the equation x equals 22 plus 3z, we're going to be plugging 88 in for the x. So here we go. Let's take away 22. 66. I can subtract. Divide by 3. 22 equals z. Okay. Well, we know where we're going to take those two. We're going to take them to the fact that the angles in a triangle all add up to 180. So you don't even have to use that equation, you know, add them up and then subtract them from 180, right? Like you guys know these have to add up to 180. So, but just so for your notes, so you know what happened. If we have this equation and we know x is 88 and we know z is 22, let's see, 88 plus 22. That's 110. So take away 110 from both sides. And hopefully my math is right. Now, you can always check. They should add up to 180, right? So I just pull out my calculator, double check me, but I'm pretty sure it is. 88 plus 22 plus 70. Yep. And you could even check it by saying some of these other things too, like the largest angle, which for us is 88. Well, that's supposed to be 22 more than 3 times the smallest. Well, the smallest is 22. If you do 3 times 22, you get 66. And then 66 plus 22 does get you 88. So you can start plugging them back into what you know from the word problem to check and see if all of them work. Okay, I'm going to fill them in right here just so it's nice and pretty, our answer. So the largest was 88 degrees. The middle was 70 degrees. And then the smallest was 22 degrees. There's our answer. So I wanted to go back to that one, this guy. And I totally described the infinitely many incorrectly, but we're going to spend a long time on it because I want to make sure you're good at it. And they gave horrible numbers on this one to where you're like, kind of dying because they're fractions. So I'm going to go slowly to make sure that you understand how they explain the infinitely many. Okay. So let me grab this equation right here. I could actually grab any, you know what? Let me grab this. Oh, that's not what I meant to do. There we go. All right. Okay. All right. So they're not going to let you just get away with infinitely many on Connect Math, right? They want you to describe it. So what you can do is I'm going to show you at least 2 different ways. Fix one of the variables, okay? It doesn't matter which one. So fix one variable. So let's say that we decide to, on this first case, fix x. All right. Then what that means is when we go to describe it, we are going to just say, okay, the answers are all x comma y comma z. No, yeah, kind of. I'm going to write an ordered pair. X, I'm just going to call x because we fixed it. That means the y and the z, I have to put those in terms of x also. I'm not going to use any y's. I'm not going to use any z's. So here's how you do that, okay? So let me put arrows here. These have to be in terms of x. Okay, all right. So I'm going to go to this equation right here to start with, because I can see from this equation that I can get the x, the z by itself, okay? Get z in terms of x. Get z in terms of x. So I'm going to solve for the z. I'm going to do that by moving 7x over to the other side. So he'll be negative. And then I'll divide by a -2. So you have z equals 7/2 x plus 5/2. And guess where I'm going to put it? In the z spot. Now we just need to get y in terms of x. So I'm going to take this top equation right here, and it's y equals, and I need all x's. The problem is there's a z in there, right? Well, I'm not going to write that z right now. I'm going to write everything else. And I'm going to put what we just got for z in the blank there. And that'll mean that I have all x's. Because I've got 7 halves x plus 5 halves. Notice everybody here is an x. So here's what we got. 3 times 7 is 21. 3 times 5 is 15. Okay, I'm old school because we weren't allowed to use calculators when I went through. So I'm going to go ahead and get common denominators here and here by multiplying by 2's, you guys. Okay, so 2 times 2, this is going to be 4x over 2, and this is going to be 6 over 2. Now I can combine, sorry, I dropped the x here. I can combine these two. 21 minus 4 is 17. And I can combine these two. 15 minus 6 is 9. And that's what y equals. So we're going to put that right here. Now let's talk about what this is. And sorry. And then there's a little such that x is any real number that they put. And this is your answer right here for how you would describe the infinitely many. Now, it's ugly. I'll do another one getting the y fixed, but let's go back to our picture really quickly. Okay. So let me make these different colors. Settings, color red, color purple. All right. And get that out of the way. Now remember, we said the solution is where the purple and the red cross, right? That's what we're trying to describe. So why is this good? Okay. This is good because now that everything's in terms of x, if somebody were to let, let's say, x be 0, in this, then they have an ordered triple. 0 is the x. If I plug a 0 into that, that guy's gone, so just 9 halves remains. And if I plug a 0 into that, that's gone, so just 5 halves remains. This should be a point on the line where those two things cross. Let's see if it's true. 0, comma, 9 divided by 2, comma, 5 divided by 2. Okay, check it out. These are right there where they cross, right? That point is. And you could get more. Okay, that's when we let x be 0. Let's let x equal 1. If I let x equal 1, then 1's going to be the x value. If I plug a 1 in for 17 halves x, if I plug a 1 in right here, you guys, it's just going to be 17 over 2 plus 9 over 2, which gets you 26 over 2, which is 13. So I got the y value. And now plug a 1 in into the last one. Plug a 1 in right there. Well, 1 times 7 halves is 7 halves. 7 halves plus 5 halves is 12 halves. There's 6. So apparently the point 1, 13, and 6 lies on the line 2. 1, comma, 13, comma, 6. Now you're not gonna, I need to shrink it down so you can see what I'm talking about. You're like, that's on the line? Yep, if I shrink it down, there. So it's on that line too, you guys. So all these points, somebody can pick whatever number they feel like on the face of the planet for x, and they can plug it in, and it enables them to generate every point on the line. So this is a possible way of describing the infinitely many. It's better than just saying, oh, infinitely many. You're going infinitely many, and here they are, okay? Now, I think that it's probably tough. Let's do it one more time, this same problem, but let me show you what it looks like if I were to fix y, okay? So what would it look like if we fixed y? Actually, let's fix z. It looked like if we fixed z. Okay. All right. So the key equations that we need again are still, you know, the original and this black one. Oh, I wonder why it didn't copy that. Interesting. Okay. You know what? I actually want this guy to be lower. Okay, if we fix Z, then our solution set looks like this. It's all X, comma, Y, comma, Z, such that Z is any number we feel like, such that Z is any real number, okay? So this means we need to get X in terms of Y and put it here. I'm sorry, X in terms of Z. And we need to get Y in terms of Z. So that everything's all Z's, right? All Z's. Well, we can get X in terms of Z very easily from this equation right here. So here we go, solve for X. So I'm gonna move the 2Z over, making it positive, and then divide by 7. That's what I'm gonna put right here. Okay. Now, we're gonna do the same thing that we did earlier, which is let's use this guy. And I wanna get Y in terms of Z. So keep the Z this time. It's the X that we wanna get rid of. Well, we already know what X is in terms of Z. Let's plug it in. Okay, 2 times 2, that's going to get us 4. 2 times, negative 2 times a negative 5, that's going to get us positive 10. Okay, I'm going to get common denominators. So that means that we're going to have to put a 1 under it and multiply by a 7. So that's 21 over 7 minus 4 over 7. 21 minus 4, I think that's 17. And then do the same thing over here or punch it into your calculators. You guys have calculators. I'm just not used to that. So that's going to be 10 minus 21. That's going to be negative 11. Okay. Let me get some notes here. Okay. So this is Y in terms of Z. So put it in right there. So for example, if you were to let Z be 0, let Z be 0 this time, okay? So if I plug a 0 in for the Z, this gets annihilated, just negative 5/7 stays. This gets annihilated, so just negative 11/7 stays, and Z is 0. Apparently, that's a point on that line where they intersected. Apparently, let's see. Okay. So he's kind of hanging out up there. Yep, you can see that he's on the line where they intersect. Okay. So it doesn't matter which one of these you give connect math. It'll accept either everything in terms of Z's or everything in terms of X's or everything in terms of Y's. It's your call. Okay.